I know they don't. You're not going to be able So hi all, we're going to get started soon, so hopefully you've already grabbed some food. If you at any point you forgot to grab food, feel free to get up and grab it as unobtrusively as possible. So for those of you who have never joined us before, this is the Smart Mobility Connection series, so sponsored by Traffic 21. And it's meant to showcase current transportation research and invite students, faculty, employment partners, members of the community to engage with that research and find out ways to be involved, provide feedback. Before we get started, I'm just going to ask if everyone can pull out their phone or electronic device and just go to this URL that's on the board. So it's mobility21.cmu.edu/check-in. There's a hyphen there. And this is just so that we know how you came to learn about the event, how many people are here to provide food for, just helpful stuff in general. So I'm just going to wait until everyone finishes that first. So yeah, those of you who just joined us, if you can just make sure to visit that URL on the board and check in. That's so we know how many people to provide food for in the future, all that good stuff. Feel free to do that. Right. So today we have the privilege of having Professor Scott Matthews here. So Scott is a professor in the Department of Civil Engineering and also the Department of Engineering and Public Policy here at CMU. So some of you may be students or research assistants. And Matthew's research here focuses on engineering, economic, and social decision making under uncertainty via large data sets, computation, and visualization. Currently, his interests are in the use of connected vehicle technologies to provide high-resolution data and vehicle performance and use to improve mobility. Scott has served as the chair of the Committee on Sustainable Systems and Technology with the Institute of Electrical and Electronic Engineers, that's a kind of a word mouthful, and on the Executive Committee for the American Center for Life Cycle Assessment. He participated in the National Research Council study on the hidden costs of energy and was a member of the NRC Board on Environmental Studies and Toxicology. He's currently involved with the ASCE and TRB committees related to data and connected vehicles. So today we'll be speaking on the applications of connected vehicle technologies to improve safety, mobility, and emissions. Please welcome.
So, thanks for the introduction, and not only are some of those things a mouthful, but the title of what I'm going to talk about is a mouthful as well as the abstract stuff. I thought a little bit more in the last couple of days about how to cram all this stuff in, and it's certainly not going to be sort of equally split across these three items, but I'm going to sort of drive hard through one of these three domains to get to a big point that I'm trying to make about connected vehicles. So I look forward to talking through this with everybody. She gave a pretty high-level overview of me, but when I give talks to audiences like this, I usually like to start with a slide like this because I don't think I'm interesting, but I'm a little bit odd in various ways. I like to think about things in three domains that I care about because of the background that I have. So I grew up in Pittsburgh, and I won't go into a long version of the story, but I was in high school, my guidance counselor said, "You're good at math and science, you should do engineering." So I applied to and came to CMU to do that, just because my guidance counselor told me to do that. I'm also teachable. So I'm an engineer. As an undergrad, I did computer engineering here and engineering public policy. I took a lot of econ classes, and so I got really excited about economics for about 5 years and got a PhD in economics. from what is now the school across the street. But most of the things that I have gotten excited about working on in my life have been highly sort of data-driven problems. I did a lot of work the first 20 years of my career in sort of the energy, environment, sustainability space. I've gotten much more interested in transportation in the last couple of years, and I'll talk about this, but I've always been interested in sort of doing it for sort of decision support purposes, right? What can we do to make things better specifically for governments and other things? So what I'm going to talk about today, I think we'll sort of see elements of these three things and perhaps understand why I'm quite so odd having no degrees in civil or environmental engineering. So a lot of people have asked me, which is an interesting group to be talking about this because many of you here do care about transportation, but for a lot of the last 50 years, transportation wasn't really considered to be super high tech. And yeah, we were using technology and there were neat things going on, but when we think about how information communication technology changed things like energy and buildings and things like that in the last 10 or 15 years, transportation was lagging a bit. But I think it's coming back and catching up in a big way, as I will say in a few minutes. But when I say it was sort of not so high tech, the kind of methods that people in transportation engineering research domain use and continue to use weren't necessarily what I would call right? So we use sensors, right? We had traffic counters. When I say traffic counters, you do things like those little detectors and intersections. Have you ever seen like those weird cutouts when you're sitting in traffic light? Why is there like a weird hexagon kind of thing at the front of the traffic light? Years ago, and still in parking lots, we put like kind of magnetic things under there to sense when a car was there. So that's a sensor. That's kind of neat, but not so high tech. When we were trying to figure out how people use their vehicles, we did surveys, or we called people on the telephone and said, how much do you drive your car per year? That's not real high tech. I mean, it's useful, it's good science and math, but again, not so amazing. To give you a sense, when we do the Department of Transportation's still official record of driving in the United States, the National Household Transportation Survey, it's done with like a telephone survey, cold calls, 25,000 households. And so we make lots of decisions from vehicle planning and maintenance funding decisions at the federal level based on cold calling people in their houses and hoping somebody over the age of 18 answers so that they're eligible to say how much they guess that they do. So, as I said, the difference is why I think about transportation now. I think everybody in the room knows that we're in this sort of huge era, specifically in the transportation space, where we have multiple coming technologies, both connected and autonomous vehicles, that are going to radically change things happen. I'm not going to really talk about autonomy much at all, except in maybe 2 slides. But the connected vehicle side is the one that I care much more about. I'll talk about it in the next couple of slides, and I think I care about it mostly because I think it's going to cause some really big changes and shifts in positive ways to society of things we can do because of all the information we'll have in connected vehicles. So let me just do a quick point of departure from some other talks you might have seen about connected vehicles. This is a popularly used slide that talks about all the different kind of connections you might have between vehicles, infrastructure, other buildings, things like that. That's all true, and I think those kinds of technologies are going to be coming, and the Internet of Things way of we're generally talking about that is sort of parallel technology development that's happening. Some of the applications that people talk about when they envision using this graphic in their slides are very high-level things, and some of them are going to have big social benefits, and some of them, frankly, aren't. But that's okay. I mean, that doesn't mean we should develop technologies. But when I think about trying to do things in this space, I think about sort of the kinds of applications, real-time or other, that could happen if we had this kind of connected vehicle kind of technology. And people certainly talk about these long-term things that we could do, such as communicate with others. And when I say long-term, I mean we can't do necessarily right this moment. Longer-term, things like communicating with other vehicles, communicating with traffic signals, right? There's vehicles queuing up. We don't need loop detectors anymore, and we're saying if there's 5 cars waiting for this light, we need to change the signal. Communicate with parking lots, right? So I don't have to keep driving around and figuring out where all the empty spaces are. And with buildings, right? Trying to optimize heating loads or cooling loads based on the number of occupants, based on how close people are to work. Those are neat things, but there's also some short-term kind of things that can be done with connected vehicles, such as, and some of these are already being done, I would say. We can communicate information, what's going on board the vehicle with manufacturers. We can do it with other kinds of service providers. And the one that I care most about, probably, is communicating with agencies. Now, there's also a relevant economic overlay to this, which is when you think about how expensive these kinds of things are in these two columns, the ones on the left are, generally speaking, relatively high capital cost things to do. Putting in IoT or connected vehicle technologies to communicate with traffic signals, parking lots, buildings, etc. That's lots and lots of high capital costs, and each individual one a high capital cost, let alone doing it millions of times. The things on the right-hand side are, generally speaking, very low capital cost things, which are just the sort of marginal cost of putting the vehicle or setting up the data stream for data. So partly because I'm lazy and partly because I'm an economist and a not so recent engineer, I tend to think mostly about the things on the right-hand side, like what kind of things can we do now, can we do that are relatively cheap, and even though I took the animation away, the things that could be socially beneficial in terms of things we could do with it. So I think a lot about short-term projects of interest and the kind of platforms that could be done, but again, thinking of things that we can do now almost immediately. So the first one that within the pitch that I want to talk about is things we can do with emissions testing of vehicles. So my first question, and since I'm going to guess that basically everybody in the room is at least currently residing in Pennsylvania, and I know not everybody has a car, but if you've had your car in Pennsylvania, you've got it inspected, you've had to do this, what do they actually do in your emission Pennsylvania? Anybody know? One guess. Go ahead.
What would you have to do to do emission testing?
What happens when you get an emissions test? What do they actually do?
Yeah, my understanding is you take it to the technician, you basically hook up the vehicle to a muffler, to a system, just kind of analyze what's going out of the muffler and let you know if it needs stacked.
Yeah, so they're doing some sort of tailpipe-based emissions test that says you have a standard, and if you're emitting below that, you pass, and if you're emitting above that, you don't pass. So that's how emissions testing works, right? Anybody have a different thought? No. Okay, well, to be clear, in general, the methods that get done to do testing of emissions are what we call direct measurement. The first one is actually putting tailpipe sensors in cars. That's one you mentioned. There's also indirect things you can do by sort of guessing at emissions in vehicles. You know, so set up remote sensors with lasers and all kinds of cool high-tech stuff on the side of roads and sort of detect plumes as cars drive by on on-ramps. These things are typically done by what we call jurisdictions. States. In some states, it's not the whole state that does emissions testing, just a couple of counties. But there's a jurisdiction that has geographic boundaries and agency directives on things to do to do. In some cases, actually even just cities. Now, the thing that you should realize about how these emissions inspection programs work, they are defined and set based on standards, to keep the same. And they typically they are done at some sort of testing interval, right? Whether it's every year, every other year, and cars might be exempted for the first 5 years because they're new, and new cars don't fail emissions tests or whatever. But they have these same general formats, which, again, similar to what you said, you drive a car in to an inspection facility, and somebody's checking to see whether it's within the limits of that. So you pass, you get a sticker, and if not, you fail, and maybe you have to do some repairs, and then they check it again. So first note of reminder here, the next 5-ish slides I'm going to talk about are based on work that my colleague Prithvi, who is sitting over there with a mouthful of sandwich, has been working on. So just sort of raise your hands away. So any of the problems you see in the next 5 slides, he's the guy to talk to when the presentation is over. And I will direct all hard confrontational questions to him at the end of my talk. And I encourage confrontational questions because I want this recorded video to get as many hits as possible. When people say, "Did you hear that crazy question from the guy?" But this is in general how these programs work, right? And these direct measurement things have been around for a while. Sometimes it's just tailpipes in cars, and while they're sitting there, we actually sort of also put like cars on treadmills, so to speak, and we like speed them up and slow them down. We still are sort of measuring emissions like that, but it's not just sort of while they're sort of sitting. And they're comparing these things to some sort of standard like grams per minute or things like that of either carbon monoxide or hydrocarbons or NOx or whatever. So the point that I want to make, though, is that the way that we actually test emissions in the United States, including Pennsylvania, and in much of the world is probably going to surprise you because we don't actually do tailpipe tests anymore. Well, we sort of do in a couple of small places, but by and large, the vast majority, 99.5% of emissions tests in the United States don't do direct measurement. They do indirect measurement, as we said before. And many states, including ours, in the last 20 years have made this transition, such that what we're doing is what we call OBD scanning. You might not know what OBD is, and that's okay. There's that little thing that looks like a big VGA port that's underneath your steering wheel in the dashboard somewhere. Looks like a big VGA port. I don't know how else to describe it, but the point is it's this sort of weird shaped thing, and that is a plug that is meant to both help the plug itself is a data link connector, which was set by manufacturers to help plug in and do diagnostic. But the communications protocol and some of the things that are done over the onboard diagnostic OBD system have been set and prescribed by regulations and work with CARB and EPA over time. And all cars sold in the United States in 1996 have one of these plug sockets. And all the dashboards in these cars also have what's called the check engine light, or malfunction indicator lamp, MIL. And all that's happening in your cars is they have these computers that are trying to check how your car is doing. And I think there's something wrong with your car. Your check engine light goes on. Most of you have cars probably know about this, and maybe it has come on. So it might surprise you to know that really what's happening when you go to get an emissions test is you're paying $35 in Pennsylvania for a technician to see if your check engine light is on. Okay? So this is the first sort of mic drop moment of the talk. But my point is that you're paying $35 for 1 minute of time for somebody to plug that in and say the check engine light is on. Let me just talk. Yeah, go ahead.
Are you getting into that issue that the German car manufacturer manipulates with that?
Yeah, we're going to talk about that in a second.
Nice.
Yep. So, but thank you, Ray. The manipulation is an important part of this problem. This is another one of Prithvi's awesome slides, and I will do my best to do it in the same good way he does. But let me just talk for a second so you understand really what I mean with this whole check engine light thing. So, cars have computers and sensors and other things built into them, such as oxygen and airflow sensors, or fuel flow sensor, or things with the catalytic converter. And there are sensors that are connected to the computer or the ECU in the car. And when some of those sensors have weird values, they trigger what we call DTCs, or diagnostic trouble codes, which is sort of like a 1 or 0 thing saying, there's a weird reading going on at a converter, fuel flow sensor or something. And these exist as sort of like variables in the computer at moments of time. But what's also happening is the collection of, or the presence of those trouble codes gets fed into the firmware of the cars, which we sort of represented here as literally a black box with different manufacturer logos on it, because the different manufacturers can see those trouble codes and decide whether that is a bad situation for emission, as required by law, to turn on the check engine. Because the check engine light, believe it or not, is primarily made to be able to identify over emissions. That's what it's up there. Now, if it's blinking fast, that means there's actually something really wrong with your car, and you need to go take it in because it might blow up at any moment. But just triggering and having the check engine light on and not flashing is meant effectively to say there's an emissions problem. So that's why those emissions tests have migrated to this system over time. And we're saying that, well, since we've designed this whole system to be able to identify when there's emission problems, we can just check that check engine light to do that. So the issue, of course, so that's how the technology is actually, right? We're triggering check engine lights, and we're checking them for emission. Let me give you just a quick baseline from data analysis that's been going on in our group for the last 5 or so years. This is data from 2016. Frankly, the other years don't look all that different. And on the x-axis, you can see the model year of vehicles. On the y-axis, you can see failure rates, right? How many of the cars you're getting the test have problems with their emissions. And you can see that there are not big problems, right? The y-axis is going from 0 to 6%. And as you probably would expect, that newer cars don't really fail that much. That's a good thing. And cars that are a little bit older, say 10 or so years older, fail at a higher but not dramatic rate of, say, 5%. And just one other thing to tell you is, again, that OBD standard came in 1996, so any car newer than 96 can be tested. And any car before that can't be tested. So there is still some emissions testing that goes on, but there's very few vehicles left that are this old. So the failure rates are still legit, but realize we're talking about very, very small percent of leasing cars. So failure rates are not high, less than 5% or so. But realize that we don't really know whether the emissions are bad. We are trusting that check engine light, and by default, the manufacturers who are in charge of turning it on to know when there's emissions problems. Now, here's your moment, right? We have problems, right, with this. First of all is we're requiring requiring everybody to go to an inspection station and pay $35 for this 1 minute of effort. We know 90+% of the vehicles are passing the current test. We're still making them drive to the inspection, and it sort of makes anybody with half a brain start saying, man, there's got to be a better way. If only we had this sort of magic technology to see what was going on with the car in real time and save those trips. Like, imagine that we had this way of sensing check engine lights and other trouble codes and all these things at all times to actually figure this out without driving. Well, of course, into vehicle technology and do that actually quite easily. So, given that we've already made this transition to indirect measurement, the OBD tests, what we envision is this idea of sort of remote and selective emissions testing programs, or IM programs, that are going to be much cheaper and much more convenient. The trick is we still want to be able to try to find cars that are over-emitting. There's plenty of data in the already existing data streams from the tests that are happening in various states to start building models to try to do this. But we want to try to do it not just to see check engine lights, but we want to try to predict actual emission and situations where they're over-emission. So we want to see if that can be done remotely and in reliable ways to find those vehicles. So just to make sure you see what we're talking about, I personally don't love the part, but I think it's useful in this particular slide. But you've got cars who are communicating with some sort of cloud-based service, and that cloud-based service is not just collecting the data, but doing some sort of thinking, statistical modeling, or other things to say, I think this car is over-emitting compared to the standard or not. And based on that, if we think it perhaps is over-emitting, perhaps we do have people then be told to go, they get an email or a text or whatever that says we need to go take this car in immediately to be tested. And otherwise, you pass. Whether we still send out emission stickers or not is kind of irrelevant, but the point is you're passing unless you're right? But that's what we're talking about, having a program like that. So in terms of data, there's lots of ways to think about doing this, and we sort of found we sort of stumbled onto a unique opportunity because a different state in the U.S., Colorado, has been transitioning more recently from the old tailpipe testing regime to an indirect OBD regime for the last 10 years. There's something else relevant that I didn't mention with respect to the way states operate. Some states have what are called centralized inspection facilities, right, where they're sort of managing, and they have small numbers of these inspection stations in counties and in urban areas. Pennsylvania has a decentralized program where basically on every corner you can find a shop that will do your inspection. So it's car dealers, small automotive repair places, Goodyear, Pennzoil, like all these kind of places can do the inspection. But in Colorado, they had a centralized system with a relatively small number of centrally managed facilities, and as a result, they had big investments in having prior direct measurement technology already put in place. So they had what are called IM240, or those sort of treadmill kind of tests that I was talking about, already installed. And they knew they were thinking about doing this transition, so what they were doing is they were collecting simultaneous tests of both real emissions tests with these IM240 machines, as well as doing the OBD tests, both before and after this transition. Right? So 5+ years ago, the statutory test of relevance that you had to pass was the tailpipe test, and nowadays you have to pass the OBD test. So for that whole period of time, they were doing both. And so you can actually look at the data and say, okay, now wait a second. We know that there's an idea of real emission. We have this OBD indirect measurement. How much do these increase? Right? So to give you a sense, there's about 5 million records that we're looking at with lots and lots of information I'm not going to go into, but is this really neat opportunity to do this? So what do I mean by we look at this data? So we have both the direct and indirect tests, and if you go for a minute and say that we assume that this check engine light is a prediction, so to speak, right? Because at best is the firmware developed by the manufacturer trying to predict when there's an over-emitting situation with code. But we also think that those direct measurement test results, or IM240 results, are the ground truth, right? It's the right answer of whether the car is over-emitting or not. You can make sort of a matrix that compares false positive, false negative, so to speak, confusion matrix, and say, all right, well, of all of the tests that were done, how many of those 5 million tests had both of the tests agreeing that it was passing or failing? Well, that's on the diagram, right? So you'd say, all right, 85% of the time, both of the tests said the car was passing emission, and about 2% of the time, both of the tests were saying it would fail. That's pretty good, 87% of the time. So But if you dig into that data a little bit deeper, it's problematic, right? Because it was falsely passing 50% of the test, right? Meaning that the test wasn't actually good enough to detect the thing. You're just using OBD kind of result. And it was also would have been falsely failing about 11% of the vehicles. So that's not a great outcome, right? So the diagonal looks decent, but the off-diagonal items are not so great. So, and I've sort of used this sort of expression before, and it's not perfect, but the idea is, how should we be happy with the number being 80, 85% or so? In some places that's, maybe a high B or a high C or like a low B. That's not all that great, right? So the question is, can we do better than that? But don't forget, we're also trying to do it remotely and without actually seeing it. So that's our goal, to try to do better. So to give you sort of a visual description of what we mean, imagine you have a bunch of cars, and the color is a little bit hard to distinguishing of the colors is a little bit hard to see. Right. When you have the blue cars, which are those you think are going to be failing the real test, versus cars that are passing that test, well, you can start saying that we have samples of them. When we draw a circle around a bunch of them, we're going to have the car, and we're saying that here's the ones we think are in the test. We, of course, have these false positive, true positive, false negative kind of rates you can find, and define, using standard statistical definitions for all of those, the sensitivity, specificity, and accuracy when you're thinking about different ways. Okay? So again, what we want to do is do better than the current system. Right? So the kinds of statistical models that you can use here can be used to classify whether we think things are passing or not. And the other thing that's really great about them is that they're not a sort of strict one input kind of method where the statistical model does all of the work and nothing can be changed. They're interesting because different jurisdictions and decision makers could, so to speak, turn the dial to get different results, right? So you can actually say, how do I want to tune this model to either find more vehicles to reduce more emission or to annoy less people, right, by having this happen. And that's actually a really good thing, because you can think of both urban versus rural and other reasons to want to be able to sort of turn the dial, and it's actually a great power that a decision maker or stakeholder in a jurisdiction might have, right? They can be trying to choose what they do. So to give you a sense, right, and I'm going to purposely not go by defaulting to all the statistical models, because they are really cool and interesting, but they're not all that exciting to talk through when there's a bunch of things I want to try to say. So if you think of, overlaying putting on the X and Y axis the false positive rate, true positive rate, as your 45 line up there, think about sort of model performance of a given kind of model with a sort of tuning parameters in there that you can choose from. All we're trying to do is say, well, here's where those false positive and true positive numbers intersect the X and Y axis for the current OBD-based system we already talked about on the previous slide. All we got to do is sort of do better than that, which means going up and to the left on this graph. So any of these spaces would be better. And so what we want to do is look at lots of different models to try to figure out how easy it is to do better than that. Okay? So I'm going to skip over a bunch of the details, but not just individual models using different data, but also specific models trying to look at specific testing of individual pollutants, not just the overall did it pass rate, but did it pass the carbon monoxide test, did it pass the hydrocarbon test, did it pass the NOx test. All of these are comparing on the left in the middle the baseline OBD test, which is not that result, and what kind of results you get from different statistical models. This particular one is doing a gradient boosting model. You've been learning about those in your either stats or machine learning classes, and sort of feeding into some sort of overall, if we were predicting an IM240 treadmill test overall result, you can see that by and large there's some imperfections. It's not always better in every single one of these scenarios. These statistical models can in fact do way better than what the check engine light is saying. And here is the tuning sort of aspect, just to talk it through for you to make you understand why the tuning could be interesting. If you think about on the y-axis talking about baseline of NOx emissions per vehicle mile driven of being, say, a little bit over 6 in average for a fleet that has emissions that have previously been happening in the background, and you expect the vehicles to be emitting about that. The OBD test should be taking a fleet of uncontrolled cars down to a level of roughly 4 or about 25% or so less, and that would flag a certain amount of vehicles on the road to get that. But from the statistical models, you can say, well, I could hold either one of those constants. Do I want to reduce more emissions and try to get more vehicles flagged in my machine learning or statistical model? Or do I want to sort of find the same amount of cars and do less emissions? So there's lots of things you could do and sort of turn that dial and say, do I want to annoy people or not? Or do I want to reduce emissions or not? Right? And you can sort of keep experimenting with that and changing it. In general, though, you use those tuning to make really useful trade-offs between those key things you care about if you're running an IM program at a state. So the point is that so far what we've been saying is you can certainly use these models to try to find high emitters. And it does support the idea that you could selectively and remotely deal with these problems. And they're going to work more reliably than just using the check engine light or the convenience test. As I said, you can deal with that annoyance factor, right? So you can be tuning them to try to deal with, either complaints you get in the first year of program implementation, or you can start relatively conservatively and start working harder and harder as time goes on. Now, I didn't put a slide on this because I was concerned about time, but there's 50 states in the U.S. and only 31 have some sort of emission testing program in their jurisdiction. There's 19 states that don't, largely rural, mostly rural states. And the other thing that's interesting is even within some states, such as Pennsylvania, not all cars have to be emissions tested. In Pennsylvania, it's basically only cars that are in Erie, State Solid, Pittsburgh, or Philadelphia that are subject to emissions testing by county of registration. And if you're in any one of the other almost 80 counties, you don't need to do emissions testing. But if you think about the way this works, if this is a connected vehicle sort of cloud system, it's not all that much harder to remotely monitor a couple 100,000 more cars that happen to not be in urban areas. And you could further decide to change the dial for those cars only and say, well, I don't really want to annoy all these people who haven't had emissions testing for the whole time they've had their car, and I don't want you to have all of these constituents screaming at us. So I'm going to only look for cars I think are, say, double over the standard, or 3 times over, or whatever you wanted to deal with those annoyance factors. So that's another benefit. We also suspect that some of those states that aren't doing emissions testing might decide to start doing it because it's relatively easy to start a program, and you don't need to put in stations, you don't need to buy equipment, and things like that. So I think there's lots of interesting things to think about related to the frequency of data collection and testing, right? We have a once-a-year system right now where you have to get your car and they check it exactly one time. That leads to lots of fraud, both positive and negative. Okay, sorry. All fraud is bad, right? But there's some fraud that hurts customers and there's some fraud that helps customers, right? So people can sort of trick or tune their car right before they go in. I've been told that there's these devices you can plug into your car and attach to your smartphone that will clear the codes of your car if you've had the check engine light on recently. And you can go in and get your car emissions tested, and it will pass because your check engine light is. And when I say I've been told, people are laughing in the audience because they've heard me say this before. I've been known to do that, right? But it was for research purposes, right? So, but my point is the technology absolutely exists. We'll talk about that in a couple minutes. But there's also the worst kind of fraud, which is people who are perhaps not as knowledgeable car mechanic owners who go in and somebody tells them, yeah, your car is not passing the emissions test, and they get sucked into paying like $400 for repairs. My point in saying that is that you don't have to do this once a year. You don't have to do it constantly. You don't have to do it second by second. But you can do this once a month, once a quarter, once a week, whatever. The data load is not high, but you could be routinely monitoring cars to check for fraud and say, well, look, the car that never failed in the past, but now it's failing. Well, it's because we're checking once a month. And that person doesn't have the opportunity to go in and trick you. Right? So there's lots of interesting things about the frequency there. But as I said, you'd still expect to be able to save many of those inspections, right? So we think we can save 90% of the visits and people don't have to drive to do that, then that's a savings. Okay, so I want to just talk a little bit about how this might work. And I'm not sure I've really talked about this in an audience like this before, but so how could a system like this work? I mean, you want to get data to do this. As I said, you grab that OBD data at the time of the test. But this OBD data, so to speak, is actually always available from the car. And if you have a GM car, like I do, actually I have one GM car and one Ford car, so I'll talk about both of those. Since 1996, there's OnStar, which they really developed initially as like a driver safety security kind of thing, like if I'm in an accident, call the police for me. but over time has really gotten embedded into the OBD system. And you can get a monthly summary in your email that tells you whether it's noticing any trouble codes in your car. It'll tell you your check engine light is on via email. Now, if you don't see it on the dashboard, that's a problem. But the point is, the email says that you know that they know. You know what I'm saying, right? So the OBD check engine light is on in your car. It's clearly communicating back in some way that doesn't involve you to OnStar, and then they're emailing it to you. So the point is, they know this data already exists. There's other ones from other manufacturers, like Ford, Sync, and BMW Connected Drive, and others. Pretty much any big volume manufacturer has some sort of connected vehicle or data sharing platform already. But we can't trust manufacturers to do emissions testing. I shouldn't say we shouldn't trust big manufacturers to be in charge of data emissions testing because of things like the Volkswagen. I don't want to overblow this and say that these car makers are all horrible and never should be trusted to do anything again. I don't think Volkswagen is the only one doing this, and I think we've seen some other less prominently public suits since then from other manufacturers. But cheating on emissions tests, it was just part of being in the automotive. I'll just say it that way. But to me, that suggests not so much that they can't be trusted, but that they won't be trusted, right? Because these are jurisdictions who might otherwise still be trying to manage an IM program and say, well, look, we're going to now move to this connected vehicle platform that Scott has convinced me to do, and Volkswagen data is all coming from Volkswagen. Well, I'm not so comfortable with that. I don't know that the citizens would necessarily be comfortable with that either. So to me, that suggests that they won't be the central player. But we don't have to rely on manufacturers, right? There's lots of ways around that. For example, and when I talked about, I hear that there are devices, this is one such of those devices. These are little sort of 3G/smartphone connected, Bluetooth connected devices that you can plug into that DLC port, the big VGA port onto your dashboard, and it will connect either directly to the internet or via your smartphone to communicate information from your car to a different cloud-based place. This particular one that has a picture of is from a company called Automatic, which got bought by SiriusXM about a year and a half ago, which is interesting because SiriusXM sells satellite radio, right? Well, their idea is they want to be a connected vehicle company. So this is one way of trying to be a connected vehicle company. Not just Automatic, but other ones exist by insurance companies. You can put this in your car, and this proves how much you're driving your car to the insurance company. It proves you don't have jackrabbit starts and really hard stops, so you're a safe driver, whatever. So you might get a safe driver discount. But what they're doing is using these data streams of OBD and other things to pass information around. Sorry.
So are these pulling raw diagnostic data that isn't filtered through the manufacturer firmware at all?
They can. It's hard. You can't see all of the information that they can collect. There's the public proprietary data, but there's no reason they couldn't deal with it. Right? Good question. Really good question. I'll come back to that too. But my point is, when I'm concerned about trust and I'm concerned about sort of data sharing, I suspect that there's going to be third party, meaning not the manufacturers, data providers and platforms out there. And so when you think about what that means, you think about all of the OnStars and everything. I was too lazy to get all of the logos for the ones I had on the previous slide, but imagine them and others like the Automatic, Donkles, and other things, all sending information somewhere or directly collecting it as part of their own activities, but being this so-called data intermediary. And the other interesting thing about that is on the right-hand side, which is, well, who cares? Big deal. You can convince a state to do emissions testing, and now they're a stakeholder. I suspect also that all of the groups listed here, as well as others, would be interested in having that information. And it's ironic that I think you could actually even sell data back to customers, right? Because even though that data is being collected, it's not necessarily being processed in useful ways for you. And you might want to know your driving patterns when thinking of buying a new car, right? And not you're going to pay $1 million for that information, but at scale that would be interesting. But again, I think there's lots of revenue opportunities and market opportunities for various people and stakeholders to do that. I also think you see that the OnStar and Ford are feeding into the box, that the other great benefit that such an intermediary would provide is sort of vetting and validation. Right? This would be well, you're telling me I can't trust Volkswagen or any manufacturer, but you're using information from the manufacturers into the data intermediary process that you're selling me for my emissions program. And so this entity in the middle could be validating and statistically checking to say, okay, this seems really strange that all of the Volkswagen cars look really good compared to all of the Ford cars or whatever. Right? So there's lots of statistical and other validation that can be done that is value added there. So I've so far spent, let's see, almost 35 minutes talking just about emissions. So I did that because I think it's one that sounds interesting and uses some heat method, and at least gives you an idea that, yeah, if you wanted to do something like that, you'd probably need some sort of service like this to enable that, and it's easy to think that in the future that is going to be how this is done. You cannot imagine that in 10 years that the de facto way of doing an emissions test, even though it's not really an emissions test, is driving somewhere and being tested if there's this way of doing it. And if nothing else, I'm going to get really annoyed with the Pennsylvania Department of Transportation next year because they love to sell us data but have no interest in anything we ever tell them. Sorry, am I allowed to say that? Where's Stan? Am I allowed to say it that way? Sorry.
Yes.
Let me re-say it in a nicer way. Maybe not. But my point is that at some point in the next couple of years, if they don't seem to get excited about us telling them to do this, I'm just going to stop worrying about Stan telling me to be nice to depend on anyway, and just start writing op-ed pieces that say, do you realize you're paying $35 for somebody to tell you whether your check engine light is on? And maybe public opinion would shift quickly against them and tell them they should start doing that. Okay, so to the rest of this slide. So that's just one sort of like teaser of why you might want to think about these connected vehicle data intermediaries as being like this really interesting path forward. But what else other than emissions, right? So I'm not going to talk in anywhere near the amount of detail that I anticipated before I sent the abstract into Kelsey and Bonnie, but there's also safety. Right? In Pennsylvania, we have both safety and emissions, and if you're in Allegheny County, you do both of them every year. There's only 18 states in the U.S. that do safety inspections for vehicles, and while many of the things that are being inspected are, you kind of need to see it to know, there's a lot of things in safety inspections that can probably also be remotely checked. And so you could probably have a significant impact on safety inspections also with that better structure. And this is the part that I'm going to talk way more about that I've sort of compressed is if this autonomous vehicle future really is coming, this is the one slide where I said promise that I talk about autonomous, I worry a lot more about the lack of dependence and maintenance that people will have on their vehicle on top of what we already have, right? So, you know, I don't want to sound old and all, but when I first learned to drive in the 80s, like my dad made me know how to like change oil and check tire pressure and check tire tread, things like that, in exchange for me getting my driver's license. Well, I don't even do those things myself anymore, let alone force my now 16-and-a-half-year-old son to do thing. And the average person doesn't really take it seriously. So from that perspective, the kinds of things that these connected vehicle data streams can do would be relevant for safety inspections, but moreover, more relevant for safety, right? It's probably going to be ways of saving even more lives as safety inspections themselves happen. And now if you start imagining having autonomous cars, they're going to have LiDAR and sensors and all these other things, and not just full autonomous vehicles, but all of the like lane warning systems and backup cameras and all those kind of things that come to depend on, those are probably going to start being part of inspection, right? Because if people are truly depending on them, we really need to make sure those systems work. But we don't have inspection standards or thresholds to do that in our state. So I think that's another way that these CE data systems can adapt. And I will say one more thing, and I will go in a little bit more detail. There's also trip level information that you can get out of these systems, right? So I will show you an example, but you can get, for example, for origination, destination, and all this stuff, which could help better model traffic and transportation flow. My colleague Sean Chen in Civil, Environmental, and Hines does a lot of this stuff, which you have seen talks before. To give you some sort of sense, when we look at those high-level transportation surveys that the DOT or the state does, you get an answer that says, you know, on average, people drive about 10,000 miles a year in Pennsylvania, and we, by default, kind of assume that Allegheny County is the same. Here's a map of population density where the more urban areas are the darkest than the rural areas. This is a county, right, that has significant difference in urban and rural, even in the county boundaries. And of course, those people drive their cars differently, right? So even though it's about 10,000 miles at the state or county level, people in Squirrel Hill who own cars drive them about 25% less. No surprise. Walk a lot more places, bus a lot more places. No surprise. So you can learn a lot about this, and this comes from data flow similar to vehicle information. But let's talk about that automatic thing that I have installed in my car and have had for about 5 years in one of my cars and only about a year in my newer car. So it gives you trip level information, which will say, here's where you started, here's where you stopped. We use exact specific addresses. I've sort of anonymize them so you guys can't see where I actually live or where my mom's house is. But my point is that there's timestamps, and they also would tell you the distance and, for example, fuel economy. Now, they're also, of course, smartphone apps, so they visualize them. And it's not just start and stop, but the exact route that you took. Right? You turned left on Murray, you went down to Shady, etc. So you have a good amount of information on every single trip available if you plug in an extra CV adapter to your car. But trust me, I am sure that OnStar knows all of this too. I'm sure that FordSync knows all this too. They're just very close-lipped about what they do and don't. They just say, we do all relevant privacy protections for your information. But they really say that. They don't really say much about what they do. But imagine you have trip-level information, and you have you know exactly how much a car is driving throughout the whole year and where they're driving. Well, you could stop worrying about fuel taxes. And I say that because some of you are saying, well, wait, how are we going to pay for transportation? Don't worry, we're going to solve that problem. But the point is, the problem with fuel taxes that many people talk about is that we have a growing number of cars who sort of aren't paying their fair share, right? So high fuel economy vehicles, electric vehicles are paying a lot less. And that's used to be a good thing when it was a small part of the fleet, because that was an incentive for getting one of these cars is you would pay less. But guess what? The roads still need to be fixed, the bridges still need to be built, and all that kind of stuff. I'm sure you've heard this in other places, but the federal fuel tax has not been changed since 1995, maybe 94, I don't know, a long time, right? Since like some of you were born. And it has been 18 cents since then. Well, let's not even go into the economics of 18 cents doesn't buy as much road or bridge or whatever anymore. The two factors that are problematic are we're still dealing with 25-year-old rates of how much to charge for taxes, and a bunch of cars are way more fuel efficient. So these highway funds have a lot less money in invested real dollars, right? The solution has been around for a long time, which is mileage-based user fees. Pay by the mile, not pay by the gallon. The problem is that many people have been trying very relatively complicated technology ways of making that happen. And even some of the most recent pilot projects that have been done in some states in the East Coast to try to do this are still involving people putting new dedicated radio transmitters in cars to broadcast their position. And I just go, well, this sounds like something that does not need an additional radio transponder technology to be able to do. You could also do this, connect to vehicle networks. If you have trip level information, you know exactly how much people drive. If you wanted to have a differential rate for a mileage-based fee for a arterial road versus an interstate highway, you could do that, right? You know exactly which routes we're taking. So here's another sort of moment, and this is a slide I added about 2 hours ago. But I want you to sort of understand the sort of business opportunity that is perhaps here. Even though it's based on 1995 rates, the amount of federal fuel taxes / vehicle fees collected is about $8 billion per year. And that's 18 cents a gallon times a whole bunch of gallons. States have long since realized they don't have enough federal funding to do this, so they've had their own state gas taxes. And Pennsylvania progressively, for once about 5 years ago, decided it was time to start really seriously raising our state gas taxes. Did so, and it's really good. That's another $80 billion a year. So that's $120 billion a year of fuel taxes being collected, right? So financial intermediaries work on the margins, right? They're trying to make money by providing a service for transferring things. And just to see like a ballpark comparison, like credit card transaction fees might be on the order of, say, 1%, right? And just simple numbers here. So what's 1% of $120 billion a year, right? I mean, so who wants to build $1 billion company, right? All you have to do is take data and convince states to use it and get rid of gas taxes. The problem is, and this is the key challenge with these mileage-based user fees, is I have a great way of charging people by the mile, but what I can't solve easily is how to stop paying for gas, paying fuel taxes when I buy my gas, right? So that's the real challenge here. Like, it's not like, do we have another way of doing this? The real problem of getting rid of fuel taxes is how to figure out how to stop paying. Right?
I was just wondering if charging them for how many miles they travel. To me, that would be a difficult tax to collect compared to collecting the tax at the fuel pump. So what happens if somebody doesn't pay a tax? I mean, you look at that turnpike, you have millions of dollars of people drive it through and not.
I mean, this is a legitimate question, right? So give or take something on the next slide. But the point here is that you can effectively figure out how to not allow people to drive based on this, or just start saying, look, this person is not paying. you could do a easy pass kind of system where you have to be able to pay in first. You have to have sort of a balance to be able to keep doing it, right? Which is how easy pass would turn player. You have to have a $50
Not start
balance.
so they can't start the car. The only way to
You can do that too. Right? So my point is like, yes, this is a challenge, but it's one that the data could easily help overcome. And it's a big money sort of think about. Right? So there is a really interesting market niche here to try to not just build emissions connected vehicle thing, but to also say, what are all of the new things I could do? I had all this kind of data, and what I really want to do is make money, and oh yeah, by the way, help society, to try to do this. And as I said, most of the stakeholders would be willing to pay for some information. In some cases, big amount, small amount, to give you sort of a sense, right? I haven't thought too much about, how much manufacturers are doing, but we've already talked about $1 billion a year at the margin to try to get mileage-based fees out of people. Instead of charging $30 per emission test, charge, I don't know, $1 for the, remotely cloud selective monitored thing. Why not agree? What do you think? Like $1.50 for the 200 million cars subject to emissions testing? That's another $300 million in revenue from doing that. Right? So there is sort of a lot of money. So I'm trying to stay as close to the original plan, how much to speak versus to save time. Point, we got a lot of other things to say if you guys ask about them, but transportation, used to be boring. Some of it still is, frankly. Pavement, I don't know how to say about pavement. But, there's this huge data revolution, not just from the changes in information communication technologies, not just because of autonomous vehicles, but because of what connected vehicles can do, and not so coincidentally, a ridiculous amount of money that you can make doing that. And as I say, I care a lot more about the impact side of things as opposed to the selling people insurance, selling people new cars. Yeah, that's great, and I'll hire somebody else to deal with that side of the business, but there's a lot of socially beneficial agency to work on here. And I think finding some of those ones that are important and interesting to lots of people is a big part. So I will pause there and take questions. All right, now for the confrontation.
Well, we probably only have time for about 2 questions, so
Who's in charge? You're in charge.
you're in charge. Go ahead.
Okay, go ahead.
From a regulation standpoint, would it require car makers, to mandate car makers to share grid level data and diagnose this data, or ultimately
Yeah, I mean,
mandate?
so let's talk about the emission testing example, right? This could be a system where what you say is this is a option you're providing to vehicle owners, right? You don't force everybody to immediately switch to do that, and you say to the vehicle manufacturers that if you would like to enable the service for people who have already bought your cars, you're going to need to transfer, so to speak, the following data either to an agency directly or to an intermediary to be used to assess. I mean, good point, right? That they would have to decide to do that. But again, you can in parallel be collecting the data. Karen, did you have a question? I saw your hand.
can defer.
You can always ask me afterwards.
Yeah, exactly. There's no other part.
Karen just doesn't want her voice on the recording.
That's okay. No, I'm curious about the rural urban thing.
Yep.
Just can you talk a little bit more?
Back about emissions?
Yeah.
Okay.
Sort of maybe some of the economic
Yeah, sure.
implications.
Right, so just to go back to that point of the talk, right? So first of all, in most rural states of the U.S., you don't have emissions testing. Wyoming, there's no, right? And even within states like Pennsylvania that have it, it's not always to all cars, right? So we have states that have, which is highly rural, believe it or not. There's a land map state is very rural, and most of the counties don't have it. So we don't ever require those cars to have. The only thing we do is there's a small part of the safety inspection test to make sure that people haven't tampered with the emission thing they have. That doesn't really count. The point is that you could expand the scope of a program relatively simply to say, okay, well, since we don't require equipment in stations, we can now make everybody try to do this. But you could still say, as a concession, that we're not going to sort of annoy every person we believe has a pickup truck that is 1% over standard. We're going to look only for the ones we think are way over standard, right? Because if we suddenly annoy, 2/3 of the county by saying suddenly making emission protection they're gonna not have to, but you could say, well, we're gonna sort of mitigate that somewhat by not trying to find the same percentage of over-emitting cars in the rural counties as we would. Likewise, for the states like Wyoming that don't currently have it, you could say, you know, for $1 a car, we could monitor your whole fleet. Right? So, does that help?
Yeah, I'm just curious if there's any impetus to do it just nationwide. Every car.
I mean, you could do it without. The challenge is the way emissions testing happens is EPA does not mandate anybody to do emissions, right? So the short version of this is that you have states who realize they have urban areas that are not in line with meeting their national ambient air quality standard, and they have to do things to convince EPA that they're going to somehow get to that level or below. And one of the easy ways that most states and jurisdictions have suggested that they will meet that is by putting in a mobile source emission inspection. So EPA historically has not forced anyone to do it. They've sort of noted that this is a really good option and should help a lot. I think it's unlikely in the next 2 years EPA will suddenly decide to do that, but in the future they could say, look, if there's technology to do this, then this is something that states should prioritize doing, as opposed to saying it's the third or fourth thing on the list.
All right, great. So that concludes our SMC for today.
I will still be here.
Yeah, this happens every 2 weeks. We also encourage you to come up and talk to Scott afterwards with any further questions. I also will note that myself and Haley, I'm going to make you raise your hand. We're part of Transportation Club, which is another way for students to be involved in transportation user activities. And just as a closing thing, just make sure that you signed in to that URL on the board and sandwich on your way out to get talk to Scott. So thank you for coming.